Hello students. Today we are going to talk about graphical representation of motion. See, we all know that graphs are one of the ways in which we represent data. For example, in a telecast of a one-day cricket match, vertical bar graphs are used to show the run rate of a team in each over. In maths also, we can solve linear equations in two variables using graphs. So, what type of graphs do we use to describe the motion of an object? To describe the motion, we can use line graphs. What do they show? Line graphs show dependence of one physical quantity, such as distance or velocity, on another quantity, such as time. So, how can we describe motion using graphs? Let's understand. See, there are two types of quantities. One is independent quantity and the other one is dependent quantity. On graphs, independent variables are mentioned on x-axis and dependent variable quantities are mentioned on y-axis. For example, in distance versus time graph, we can say that distance is dependent and time is independent quantity. See, understand this. When we say distance is dependent quantity, it means that whatever the distance we cover, it completely depends on time. To cover more distance, we take more time. But whatever the distance we cover, we can't change the time, right? And this is what makes the time independent quantity. Because time is not dependent on distance, but distance is definitely dependent on time. Now, look at this graph. There are two mutually perpendicular lines, OX and OY. This OX is called x-axis and OY is called y-axis. And this point, which is a point of intersection of these two axes, is called origin. And its coordinates are 0, 0. See, both the variables are shown using proper scale. So scale is very important here. This origin, it shows the value of both the variables, that is dependent and independent. Because this origin is at the intersection point. And that's why they are 0, 0. Now, let's say this is distance versus time graph. Means here, this is time on x-axis, which is independent variable, and on y-axis, there is distance, which is dependent variable. So, here we can say that at x1 time, the distance covered by the object is y1. Look at this point. At x1 time, the distance is y1. At x2 time, which is here on x-axis, if we just go here on y-axis, then here you can see this point y2. So, we can say that at x2 time, the distance covered by the object is y2. And so on. And once we plot these points, then we have to join these points. Remember, what type of graph we are getting is completely dependent on the type of motion we are dealing with. So, when we join points, there may be different types of graphs. It can be a line which is parallel to the x-axis, straight line that is moving upward. It can be non-linear line showing ups and downs. And it can be parabolic curve. We will see each of them in our next session.